Alright, let's take a deep dive into this fascinating little device, the miniature circuit breaker. It might just look like a simple switch on your wall, but it's actually a highly sophisticated and completely automatic safety mechanism, the unsung hero of your home's electrical system. This cutaway view reveals its secrets, showing us how it protects you from two very different kinds of electrical dangers: the slow, creeping danger of an overload, and the sudden, violent danger of a short circuit. First, let's trace the path of electricity during normal, everyday operation. The power comes in, flows through this first component here, labeled the overload protection metal sheet device, which is a more technical name for what's known as a bimetallic strip. Then, it continues through the copper coil of the short circuit protection electromagnetic release, moves across the contact group which you're physically touching right now to let the power through, and finally flows out to power your lights and appliances. Everything is fine. Now, let's imagine a scenario. You've plugged in a space heater, the microwave, and a toaster all into the same circuit. This creates an overload. The circuit is now carrying more current than it was designed for, but not a catastrophically huge amount. This is where the bimetallic strip comes into play. Think of it as two different types of metal, like steel and brass, laminated together. As the higher than normal current flows through it, the strip begins to heat up. Because the two metals expand at different rates, this heat causes the strip to slowly and predictably bend, like a wilting leaf. This bending action is precisely engineered. The overload debugging fixing screw is an adjustment set at the factory to ensure that the strip bends just the right amount to trip the breaker at exactly its rated amperage, say 20 amps, and not a moment sooner or later. As it continues to bend, it will eventually push up against a tiny lever inside the central mechanism. But what about a far more dangerous event, a short circuit? This is when a live wire touches a neutral wire directly, creating a sudden, massive, and almost instantaneous surge of current hundreds of times the normal flow. For this, the slow heating bimetallic strip is completely useless. It's like trying to stop a speeding car with a gentle push. That's why we have a second, independent system, the short circuit protection electromagnetic release. That copper coil you see is a simple electromagnet. When that massive wave of short circuit current rushes through it, it instantly generates a powerful magnetic field. This magnetic force yanks a small metal plunger or armature, which then slams into the very same trip lever that the bimetallic strip would have slowly pushed. It's the difference between a slow, steady push and a lightning-fast hammer blow. So, whether it's the slow push from an overload or the fast slam from a short circuit, both actions trigger the same thing, the mechanical locking handle device. Think of this as the heart of the breaker, a complex assembly of springs and levers set like a very sensitive mousetrap. When the trip lever is nudged, it releases the stored energy in a powerful spring, and with a loud snap, it forces the contact group to fly apart, breaking the path for the electricity. But the job isn't quite done yet, because electricity is stubborn. As the contacts separate, the immense electrical pressure can cause the current to leap across the air gap, forming an incredibly hot and bright electrical arc, basically a man-made bolt of lightning. This arc is dangerous. It can melt the contacts and even start a fire. To deal with this, the arc is immediately forced, by its own magnetic field, up into the rapid arc extinguishing system, which is also called an arc chute. This is that stack of parallel metal plates. The arc chute's genius is that it takes that one powerful, hot arc and splits it into a series of smaller, cooler, and much less powerful arcs between the plates. By dividing and cooling the arc in this way, the system safely extinguishes it in just a few thousandths of a second. Only then is the circuit truly and safely broken, the danger averted, and the breaker sits there, tripped, waiting for you to find the problem and reset it.